So this is a short discussion on the material in section 6.1. It's actually a review, and I can't remember exactly what section it came from, but we did talk before about how the distance traveled is the integral, it's the definite integral of the velocity. And so that basically, I kind of have the formula summarized right here. So the distance, let's say we have some kind of velocity function. This is actually a problem from the book, problem 6.1, number 50, the book, the online homework. So problem number 15 from section 6.1. But that's basically that formula I have right there. The distance traveled from time t1 to time, let's say we start sometime t1 and we end at time t2. The distance traveled is a t1 minus t2. So this will give us the final, not the total displacement, because we might be, the thing to remember is that positive velocity, we assume we're going, positive, we're moving to the right. A positive velocity, we're going to the right, or perhaps we're going up. And a negative velocity means we're traveling to the left or possibly traveling down. So either we're going, horizontally or vertically. So if we're going horizontally, positive means we're going to the right, and negative means we're going to the left. And so that integral, this integral right here, is the sum of the positive and the negative terms. It's not the total. It's not the total displacement. So let's say, let's say at time t equal to 0, you start walking and you walk a mile and and then an hour later, so you go like a mile and then you kind of go backwards, follow the same path and you're in the same place. So the integral would actually give you 0, even though you've walked 2 miles, whereas the total displacement would actually be 2. Um, so let's just actually look at this problem, right? So the second problem that I'm going to talk about, we'll deal with this, but let's just look at this problem right here. So at time t equal to 0, a train approaching a station starts decelerating, and when it starts to decelerate at t equal to 0, we're told, you have to read this carefully, that the train is moving, because I kind of missed that at first, is moving at 160 miles per hour. And then so how far, there's two questions, and actually I already solved the first part. Okay, how far does a train travel between time t equal to 0 and time t equal to 0.1 hours? I guess that's like six minutes, I guess. Okay, anyway, and then I guess the next one would be, from 0.1 hours to 0.4 hours. So, well, like 8. So I didn't do that part, but I think if you see how I did the first part, the second part is easy. Okay, so we know we're given an acceleration function. So the first thing we'd have to do is we have to find a velocity function. Well, we know the velocity is the antiderivative of the acceleration. So we have to find we have to, solve this indefinite integral. So first, so right now what we're trying to do is get a velocity function. We're given an acceleration function. And we know that, let's see if I can, we know that v prime of t is a of t. So we have to solve this differential equation. And we're also told that v of 0 is 160. Okay, so by now this shouldn't be too bad, I hope. So we have this indefinite integral minus 1280, right? It's given right here in the problem. It's decelerating, so that's at the negative part. We're decelerating, so the velocity is going down. So it's negative 1280 over 1 plus 4t to the third power. And we're going to find the antiderivative. Okay, so we have to be careful because we kind of have to undo the chain rule. So so the inside function is 1 plus 4t. du is equal to 4 dt, right? And so we solve for dt, and we get dt is du over 4. Okay, so that dt, so I want everything in terms of u now. And I just replace 1 plus 4t with u. And so we end up with the integral of negative 1,280 over 4, u to the negative a third du. And so, yes, we just add 1, right? So we just use the power rule. We just add 1 to negative 3 and then divide by, which is negative 2. And then then we divide by negative 2. So we get negative 1280 over negative 2 times 4 times u to the negative 2 plus c. And just simplify, we get 160, and then go back to the t variable. We get 160, 1 plus 4t to the negative 2 plus c. Some of you could possibly do that in your head. I would just be really careful about that. I've had students who try to rush and then they make a mistake. And if it's a test, then wrong is wrong, even if you know the right answer. Just be careful. with that. Okay, so we're told the velocity function is 100. So we know what now we're told. So we take the antiderivative of the acceleration and we get the velocity is 160 times 1 plus 4t to the negative 2 plus c. Well, now what's c? Remember, luckily, um, we're told that the velocity is 160 miles per hour at 0. So we just plug 0 in there. So we know that this expression here is 160 when t is 0. So we just plug in t equal to 0. So we know that 160 over 1 plus 4 times 0 to the negative squared plus c is 160. So you get 160 plus c is 160, or c is 0. So our acceleration function just turns out to be, I'm not kidding, I meant our velocity function just turns out to be 160 over 1 plus 4t squared. And now we have to integrate again. Okay, so now we want the distance traveled from time t equals, so that velocity is always positive, right? So you're never going to get a negative. So you're not going to the right or to left. You're always going in one direction. The velocity function doesn't change its sign. When I say the velocity function, I mean 160 over 1 plus 4t squared. You plug in t in there, you're going to get a positive number. Okay, so we're traveling in one direction the whole time from time t equal to 0 to time t equal to 0.1. So that's a tenth of an hour, 6 minutes. So we just evaluate the definite integral 160 from 0 to 0.1 over 1 over, let me say it again. We evaluate the definite integral of 160 over 1 plus 4t squared. And I'm going to just use substitution again. Okay, so we let u equal, the inside function is 1 plus 4t. And again, we have du over 4 is dt. And now let's change the limits of integration. So when t is 0, right, we just plug into this formula right there. When t is 0, u is 1. And when t is 0.1, again, we just plug in 0.1 into this formula right there. And we get 1 plus 4 times 0.1, or 1.4. So this definite integral, 160 from 0 to 0.1 over 1 plus 4t squared, becomes the integral of, and we're going to replace dt with du over 4. So it becomes 160 over 4 from 1 to 1.4, 1 over u squared du. And we just add 1 to the exponent and divide by, which is negative 1, and we divide by negative 1. So we end up getting, we evaluate the definite integral 40 over negative 1 times 1 over u from 1.4, from 1 to 1.4. Again, we just evaluated the endpoints. So we get negative 40 times the expression 1 over 1.4 minus 1. And that just turns out to be negative 40 times negative 0.4 over 1.4, which is 16 over 1.4. So that's approximately 11.429 miles per hour. So the problem said to evaluate to, I think, to the 3 most significant digits, which is what I did. And then you can just solve the second part by evaluating the integral from 0.1 to 0.4, 160 over 1 plus 4t to the negative 2 dt. It's the antiderivative we did. Where you'd have to change the limits of integration. Okay, so just to summarize what we did here. So this is just a displacement problem. We're summarizing, right? We're just using this formula right here, which we did before in an earlier unit, probably not that long ago, except everything seems like a blur to me by now. Okay, so but what was unique about this problem, we're given the acceleration. We actually had to integrate twice. We had to integrate the acceleration function to get because we need a velocity function to get the distance traveled. But to get the velocity function, we had to solve this differential equation. So we had to integrate the acceleration and then solve for the constant c using the fact that basically it's an initial value problem. We get v of 0 is 160. And then once you get the velocity function, you just have to integrate from 0 to 0.1. Okay, so now let's do problem. Now, I guess if we were in the classroom, I'd say, are there any questions? Maybe some people would be ask, or some people wouldn't ask. I don't know. I always teach at nights. I always would teach at nights. I think a lot of the students were tired. They came from work to the classroom. Okay, anyway, I don't blame them. Okay, so students, here's kind of a fun problem. Okay, so here we have this velocity function. It's a little, got to be careful. So because we have this velocity function. Sometimes the velocity is positive, sometimes the velocity is negative. So sometimes you're backtracking. So sorry, so let's say you go, you walk a mile east, and then you stop and just turn around and walk a mile west. You're back in the original position, but you've walked 2 miles. It's not like, someone might look at you and go, oh, they check in you a time t equal to 0. An hour later, oh, you're back where you started. Maybe they think you haven't done anything. You've really walked 2 miles. Okay, uh, so in that interval 0 to 8, there's times where the velocity is positive, there's times where the velocity is negative, and so it says, okay, so the first part is find where the velocity. Basically, it's the first two parts. We have to find where the velocity is positive and negative. So I just factor, right, and then we use our friend. Remember what we did? So the velocity is t minus 7 times t minus 5 times 3. So we know that the velocity is 0 at 5 or 7. And we just find so the velocity is always positive. It's either going to be positive or negative in the intervals from, we have these intervals, 0 to 5, 5 to 8, 5 to 7, and then 7 to 8. So the sign isn't going to change. It's either going to always be positive or always be negative, because it's only 0 at 2 places. So it can't be both positive and negative in, let's say, like the interval from 7 to 8, because otherwise the velocity would be 0 at some third point, which it's not. Okay, so just take a 1 point in each interval. So like at v of 4, the function, and I don't even care what the value of the velocity is. I just want to know whether it's positive or negative. So v of 4, it's positive. Okay, so from 0 to 5, it's always positive. So let's look at v of 6, which is in between 5 and 7. Well, it's negative, so the velocity is always negative between 5 and 7. And let's take I think I took v of 8. Maybe I shouldn't have taken. That's actually not in the middle. But let's take v of 7.5. I guess it doesn't matter. I mean, v of 8 would have been fine too, because there's only 2 zeros in that function. If I extended the domain out to 9, but let's take something in the midpoint. And again, v of 8 is actually fine, but I'm being kind of silly right here. And then v of 7.5, well, that's positive. And so the velocity is positive in the interval from 7 to 8. And okay, so from 0 to 5, the object is going to move to the right because the velocity is positive. Oh, so then at 5, at 5, the time equal to 5, start moving to the left. And then at time equal to 7, we start moving back to the right. Okay. Yeah, so it's in times of seconds. Okay, so now let's just look at B here. B, okay, what do we have to do now? Okay, so we found where the velocity is positive, or we found where the direction goes to the right, and we found where the movement goes to the left. And so now we want to find the displacement of the particle. So that's where we add up. So the displacement is not the total amount traveled. It's we add up the positive parts and we add up the negative parts. So that's what I'm saying. If you like, what's the displacement? You start at some fixed position, you go 1 mile east, turn around and go 1 mile west. Your displacement at the end is 0, where the total displacement is 2 miles. That's the total. That's how much you've actually traveled or actually walked. Okay, so let's just, so all we have to do is, for the displacement, we integrate from 0 to 8. We just compute that definite interval, factor out 3. And so we get, I think we can do these antiderivatives now, especially with the power rule. We're going to integrate t squared minus 12t plus 35. Yes, we get t cubed over 3. For 12t, we add 1 to the exponent, divide by 2. So you get 12 over 2t squared plus 35t, and we're going to evaluate from 8 to 0. So, it's 0. We know it's 0. It's 0, but I put it in anyway, just to remind ourselves, because a lot of these integrals, one of the lower limit is 0. So, but we want to remember it's the top minus the bottom. Okay, so a lot of times I think I have seen students, there's so many integrals where the bottom part is 0, the bottom value is 0, that they forget to subtract off the bottom part. Okay, so anyway, if you evaluate it, so at 8, we get 8 cubed minus 18 times 8 squared plus 105 times 8. Of course, then minus 0 cubed minus 18 times 0 squared plus 105 times 0. So we get 200 meters. So the displacement is 200 meters. Now remember, we're going, so in the end, you're 200 meters from the starting point. Now you've probably gone farther at some point than 200 meters, but then you're backtracking. Okay. So, okay, so what's the total displacement? So we have to add, okay, let's compute the amount of the distance traveled to the right, and then we'll add the absolute value of the distance traveled to the left. Okay, so traveling to the right, we're going to get a positive distance. Traveling to the left, we get a negative distance. So let's add up the displacement just for the positive velocities. So the velocity is positive from 0 to 5, and it's from 7 to 8. So it's our friend 3t squared minus 36t plus 105. And I could say we could do this in our sleep by now, but I will tell you, when I was preparing the solution, I kept forgetting to put this t squared. I forget putting the exponent of 2. So that's the thing. This math is so hard. It's so easy. One little mistake makes you miserable. Anyway, okay, so the antiderivative is t cubed minus 18t squared plus 105t. We evaluate from 0 to 5. And then again, from 7 to 8, it's again the same antiderivative, t cubed minus 18t squared plus 105t, now from 7 to 8. And so then we just evaluate at the endpoints. It's f of 5 minus f of 0 plus f of 8 minus f of 7. And then, and so as it turns out, yeah, we're actually traveling 204 meters to the right. So from 0 to 5, we travel 200 meters to the right. And then from 7 to 8, we travel another 4 meters to the right. So altogether, we travel 204 meters to the right. Even though at the end, our displacement is just 200. Well, that's got to mean we've moved 4 meters to the left, but okay. But let's just compute the 4 meters to, let's compute the distance traveled to the left. So the velocity is negative from time t equal to 5 seconds to t equal to 7. And there's our friend again, 3t squared minus 36t plus 105. I don't think I made a mistake this last time computing the antiderivative. Yeah, so it's t cubed minus 18t squared plus 105t. And we evaluate from 5 to 7. So the antiderivative, yeah, so just plug in 7 and 5 in the antiderivative. So it's f of 7 minus f of 5, and we get 196 minus 200, negative 4. So the negative sign means movement to the left. Okay, so the distance traveled to the left is 4 meters. So the total displacement is the distance traveled to the right plus the distance traveled to the left, and you get 208 meters. And that's all, students. I'm going to stop the recording.